Hello everybody. Thank you for coming to this session during your lunch break to talk about 5G. My name is Alexis Duque. I'm Director of Research at Rtone, a design house working in the field of the Internet of Things in Lyon. We have also some open position and we are looking for our Cloud IoT project manager. So during the next 15 minutes, we will talk about 5G. I will introduce you some of this word. I will try to explain what massive MIMO mean, what is mmWave, what is the 3GPP. But before that, a little disclaimers. I would like to say that mobile generation 2G, 3G, 4G doesn't reflect really technical evolution. It's lots of marketing and branding term. Mobile communication generation result from many evolution and they are not perfectly distinct. But first, who is defining the mobile communication standards? There are different stakeholders that are involved in the mobile communication standardization. First, it's the 3GPP that are all the telecommunication standard organization, that is the ETSI in Europe and the ITU in the United States. There are also leading network operators like Post Luxembourg, Telefonica, Orange, and also the 5G PPP that are kinds of European initiative between institutional, commercial partners. So there are Cisco, Nokia that are involved. First, before 5G, let's go back 20 years before. Let's start with 2G. In the 19th, the technology behind 2G is the GSM. So you don't have internet on your smartphone with that, just the voice. Then in the years 2000s come the 3G with the data and the technology behind that, it's the WCDMA. Few years later comes the 3G plus, and here the technology is the HSPDA. And finally, recently, the 4G with the LTE, the long-term technology evolution. And it increases the data rate, it improves the latency, it provides other services. But what it will be 5G in the next years? So the guys at the 3GPP define different targets for the 5G. First one is to enhance the mobile broadband, providing higher data rates. It's for video broadcasting or virtual reality. The other target is a low latency for critical applications like vehicular communication. And the third target is massive IoT. There is to provide more and more devices to internet connectivity and also industrial IoT. So what are the performance indicators? The first is to improve the data rate, providing more data and more throughput to the end user. The second is to improve the spectrum efficiency, to be able to communicate at high speed, to reduce the latency, and to provide better connection density, to have more users connected in the same place, and improve the network energy efficiency, reducing the power consumption on your device, to improve the battery life of your smartphone, and provide a better throughput in the same place. So what is our roadmap for that? What we can see is that to define a standards, it takes about 20 years and maybe more. So right now, the 3GPP will release the release number 16 in June 2020, and then it will be the release 17 in 2021. So they are the release related to 5G. But how we will be able to do the 5G? How we will provide better throughput, reduce the latency? There are 5 different points to do that. The first one is to provide a new radio spectrum, to have a new radio technology for multiplexing, to improve the spectrum efficiency with new spectrum usage techniques, to provide energy-saving mechanism, and finally some application-specific improvement, like for vehicular communication or for the Internet of Things and for the industrial Internet of Things. So what will be the spectrum for the 5G? The first one is 700 megahertz. The second is 3.5 gigahertz, and finally the millimeter wave in the 26 gigahertz. So what millimeter waves is a new technique, a new spectrum, very directive technology, which will be able to provide at very short distance throughputs up to 1 gigabit. Here is a demo that has been shown in the Mobile World Congress this year. About the spectrum usage techniques, there are many different technology involved into that. It's at the physical layer, and I just will introduce the two first, that are the beamforming and massive MIMO. Massive MIMO is a fact to have many antenna into your device. In fact, your antenna on your mobile phone and at the base station will be a matrix of different antenna components. And thanks to that, we will be able to do some beamforming and beam steering. Beamforming is a fact to make your beam of your signal very directive and be able to change it at the time. With beam steering, you will be able to dynamically adapt the phase of your signal to change the directivity of your radio signal. About the energy-saving mechanism right now, there are different techniques. The most important is to be able to totally switch off the radio of your smartphone when you are not communicating. Right now, about the Capex and OPEX reduction technique, so we would like to reduce the deployment cost for the operator and to reduce the operational expenditure. So for that, we will put everything into container, into virtualization, into software. So all the components of your core network of the mobile communication network will be software. So you will be able to dynamically adapt where are the computation capacity and capabilities, to dynamically offload the computation and to adapt depending on the number of users in the same space. The other techniques is the mobile edge computing. So we will offload the computation from the cloud to the network, to the router, to make them more powerful. And thanks to these two previous techniques, thanks to edge computing and software-defined network, we will be able to do the cloud radio access network, that's our CloudRAN. So there, instead of having all the baseband signal processing into the base station, so we will offload it to the cloud. So in fact, it's kind of software-defined radio. So all the signal processing at the physical layer can be done in data center or in edge nodes. So there, we will be able to dynamically change where are the capability of your network. About the application specific improvements, so in the 5G there will be something that is called V2X, that are for standards protocols for vehicular communication. So to make your vehicle communicate together or to communicate to the infrastructure, to make them smarter, and it will be really useful for autonomous vehicle. Other application-specific improvements is for the Internet of Things with standards adapted for low-end nodes. So what are the next steps? What will be coming in the next few years? Do you need right now to buy a 5G compatible smartphone? So at the end of this year, and it's already done for some country, the new spectrum will be released. Some of them were used in the past for the TV broadcast, for instance. In different country, there will be option to make the operator buy the spectrum. In some countries it's already done. In others it's currently happening. It depends of the country. And there is already, and there will be more and more pilot city with some experimentation. There are some experimentation in France, there are some in Luxembourg, there are another one in Barcelona. Yeah. And what is a European roadmap? So in the next year, in 2020, normally all the ocean and the frequency attribution will be done. I know that in Belgium it will not be possible because of some issue, and it probably will be done in the next year, in 2021. The European Union request each country to have one city with 5G in the next year, in 2020. But for you, for all the users, the real 5G will be available only in 5 years with the 5G new radio, with new use case, with improved throughput and network capabilities. Thank you for your attention. I think that we have 2-3 minutes for question, but I'm already available during the next of the week. Thank you.